and this is Tier 3 Lesson 6, Rational Roots Theorem. So now we're going to use our rational roots theorem, and then we'll use synthetic division to find all the roots. Well, we need factors of our constant term of -4. So the factors of -4 are 1 and 4, 2 and 2, right? And then plus or minus, plus or minus, plus or minus. And our leading coefficient is 1. So factors of 1 are just plus and minus 1. So all possible rational roots are p divided by q. So 1 divided by 1, 4 divided by 1, and 2 divided by 1. So plus or minus 1, plus or minus 4, plus or minus 2. There's 6 possible rational roots. And then we'll use our synthetic division to find all the zeros. And since this is a 4th degree polynomial, we can have up to 4 roots. No more than 4, but we can't have less. So let's just start using our synthetic division to find the roots. Well, our polynomial is 1 x to the 4th. There's no x cubed, so remember I need to put that 0 in as a placeholder, plus 3x squared. There's no x, so I need another 0 as a placeholder, minus 4. So as I set up my synthetic division, 1, 0, 3, 0, -4. And now I'm going to test my roots. So I can start with 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. And -4 plus 4 is 0. So 1 is a root, right? Which means the factor is x minus 1. Okay, and then our leftovers, right? This is our constant. This is 4x. This is x squared. And this is x cubed, right? And then we could say times x minus 1, right? That was our original root. So now I want to use synthetic division with this polynomial to break it down even more. Now I can try to use 1 again, because since 1 worked, it could happen again. Remember, they could have that multiplicity of 2. But I'm going to try something different. Let's try -1. 1 times 1 is -1. 1 plus -1 is 0. -1 times 0 is 0. 4 plus 0 is 4. -1 times 4 is -4. And 4 plus -4 is 0. So that worked again. So -1 is a root, meaning the factor is x plus 1. Remember? So this is our constant term is 0x plus 4. And this is x squared plus 0x plus 4. Okay, and then the other two roots that we had, x plus 1 that we just found, and x minus 1 from up here. Now, if I take my x squared plus 4, I know that I could set this equal to 0 to find my root. And if I were to solve this, I would subtract 4 from both sides. And then I would need to take the plus or minus square root, okay, which makes this just x, right? Square root and square cancel. And then this I need to break down. So I could break this down into 4 and -1. Well, the square root of -1 is I, and the square root of 4 is 2. So I get x equals plus and minus 2i. So these are 2 of my roots. Then my other 2 roots were 1 and -1. So my 4 roots are 1, -1, 2i, and negative 2i. So I had to start with my rational roots theorem to find some of my roots. Then I used synthetic division to break my polynomials down. Then I kept going using synthetic division to break my polynomials down. And then when I get this quadratic function, I can do things like set it equal to 0. I could factor. I could use the quadratic formula. All of those things work. Okay, these are my last two roots, but they're imaginary. So I only have two real roots and two imaginary roots.